Hey guys, it's Miss Johnson and I'm here to bring you our notes lesson for Unit 2 Learning Target 5. Today we are talking about multiplying binomials. So binomials are things with two terms. So we're going to take things with two terms and multiply them together. So one method that you can use to multiply binomials is to draw a box, set up a box. When you set up a box, this is really just a way for you to organize the distribution. You've got two sets of distribution that you have to manage, and that can sometimes lead to a lot of terms. And so it's nice to have a box because that helps you organize your terms. So this is our method for using the box. We're going to set up the box. We're going to put one monomial on the top and one on the side. Then we multiply terms to the inside of the box, then combine the like terms and write them in standard form, which these things are really the last two steps of any sort of simplifying expression process. So let's try number one. In number one, I have the quantity of x minus 1 times the quantity of x minus 4. So really what's happening here is you have two sets of distribution. This first x needs to be multiplied by both terms behind, and this negative 1 also needs to be multiplied by both terms behind. So it's two sets of distribution, which can be kind of tricky. It can be hard to manage all of the terms. So a lot of times we'll set up a box. When we set up a box, we need it to be 2 by 2. We put one monomial on the top, so x minus 1, and then the other monomial on the bottom, on the side, x minus 4. On the inside of the box, we're going to multiply all these terms. So x times x gives me x squared. X times negative 1 gives me negative 1x. X times negative 4 gives me negative 4x. And negative 4 times negative 1 is positive 4. So then within that box, I want to look for like terms that I have. I see an x squared. Then I see two x terms. These terms right here are like terms. So those two I'm going to combine together. And then I have the constant of 4. So when I write out my expression, my x squared, it comes first because it's the largest exponent. Then negative 4 and negative 1 is negative 5x. And the end there, I have the constant of positive 4. And that is my simplified expression. So it's two sets of distribution. You have a distribution from the first term, but you also have a distribution from the second term. And it gives you 4 different terms that you then have to simplify together. So this box just really helps us stay organized and make sure we didn't miss anything. So let's try it again. In number 2, I have x plus 2, the quantity x plus 2 times the quantity x plus 5. So I have x times x, which is x squared, and x times 5, which is 5x. Then I have 2 times x and 2 times 5. Okay, so when I set up my box, I have x plus 2 on the top and x plus 5 on the bottom, or on the side. I keep saying bottom, I mean on the side. Then when I multiply on the inside, x times x gives me x squared, x times 2 is 2x, x times 5 is 5x, and 5 times 2 is 10. My like terms, once again, are the x terms that are kind of on that diagonal. I have x squared plus 7x plus 10. Let's try the next one. So some of you may say, well, do I have to set up a box? No, you don't have to set up a box. You could just do the distribution and multiply as you go and make a list of your terms and then combine them from there. So that's what some people choose to do. I'll show you that in number 3. So I have x plus 1 times the quantity 2x plus 1. This x needs to get distributed to both parts behind. This 1 also needs to get distributed to both parts behind. So again, it's two sets of distribution. So x times, if I do that distribution now, x times the 2x gives me 2x squared. X times the 1 gives me 1x. Then I go to the second set of distribution. 1 times 2x gives me 2x. And 1 times 1 gives me 1. So instead of setting up a box to stay organized, I just made a list of my terms. And again, this works, but you just have to make sure that you don't drop anything, you don't miss anything, you don't forget to do the second set of distribution, which all those things are common mistakes. And when you have the box set up for you, you really avoid making a lot of those mistakes because you have a method of organizing your terms. So I made my list here. Now I'm going to look for my like terms, which are the 1x and the 2x. So I have 2x squared by itself out front, then 1x plus 2x is 3x, and then 1 behind. Let's try that again in number 4. In number 4, I have x times x and x times negative 3. And then I have the second set of distribution, which is negative 1 times x and negative 1 times negative 3. Be careful with those negatives there. You don't want to drop those. So let me make a list of terms. I have x times x, which is x squared. Then I have x times negative 3, which is negative 3x. Then I have negative 1 times x, which is negative 1x. And negative 1 times negative 3, which is positive 3. So there's all my terms, and then my like terms are these x terms in the middle. So x squared is by itself out front, negative 4x behind, plus 3. All right, I'm going to go back to the box method here. I'm going to set up my 2 by 2 box because I have a 2 by 2 binomial, or I have a 2 by 2 multiplication, this binomial and that binomial. I have 3x and 1, x and 2, and then I multiply inside. 3x times x is 3x squared. X times 1 is 1x. 3x times 2 is 6x, and 2 times 1 is 2. My like terms are on the diagonal, which is great. That doesn't always happen, by the way, but it does if they're in standard form. So just look for your like terms. This is an x term and that's an x term. So I have 3x squared plus 7x plus 2. In the next one, here's my box. Again, I have a 2 by 2. 2 terms there, which is a binomial. 2 terms there, which is a binomial. X squared and 3, 3x and 5, and then multiply inside. 3x times x squared is 3x to the third. 3x times 3 is 9x. 5 times x squared is 5x squared. And then 5 times 3 is 15. Then we go ahead and combine those like terms. Oh, you know what? Haha, just kidding. In this case, I don't have any like terms. I have a power of 3, a power of 2, a power of 1, and a constant. So in this case, I'm keeping all 5 of those terms, or all 4 of those terms. I just want to make sure that I write them in decreasing order of the exponent. So 3x squared plus, 3x to the third plus 5x squared plus 9x plus 15. So all 4 terms are kept there because none of them are like terms, so none of them can be combined. All right, next one. Now when we are multiplying a binomial squared, when you have a binomial that's raised to the second power, or really any power, that's just telling you how many times you need to multiply that thing by itself. So if I have the quantity x plus 2 raised to the second power, that really means that I have 2 of this whole thing. So that's x plus 2 times another x plus 2. X plus 2 times x plus 2 ends up being a binomial times a binomial. So I can set up a box here. And I can do x and 2 and x and 2. X times x is x squared. X times 2 is 2x. X times 2 again is 2x. And 2 times 2 is 4. When I put my like terms together, I have 2x and 2x. That gives me x squared plus 4x plus 4. So let's take a look at number 7. What you really want to be careful of here, a lot of students look at a question like this, and they want to do x squared plus 36 and call it good. Now, I hope you're actually listening to me right now and not just watching, because this is not correct. That's wrong. That does not help you. You lost the whole middle terms when you do it that way. I need to make sure that I have x plus 6 times another x plus 6, and that I get both sets of distribution. So that's x and 6, x and 6, that's x squared, 6x, 6x again, and 36 at the end. When I combine my like terms, I get 6x and 6x, which is 12x. That's x squared plus 12x plus 36. So check this out. If you would have gone with this one up here, you would have lost the whole 12x in the middle. And that's a problem. That's not okay. So you have to make sure that you do both sets of distribution and that you don't lose those middle terms. Okay, let's try number 8. So 2x plus 1 times itself 2 times is 2x plus 1 times another 2x plus 1, which gives me, if I just do distribution here, I'm just going to do distribution and make a list of terms. So 2x times 2x is 4x squared. 2x times 1 is 2x. And then 1 times 2x is another 2x, and 1 times 1 is 1. I end up with 2x and 2x in the middle. That's 4x squared plus 4x plus 1. All right, before we move on to the next example, you've seen me do both methods. You've seen me do the box, and you've seen me make a list of terms and combine. What I want you to recognize is that this is really just 2 different ways of doing the 2 sets of distribution. You have 2 sets of distribution. It doesn't matter which method you use to me. I don't care. A lot of people like the box because it keeps their terms organized and it makes sure that they don't lose anything. But some people are confident enough and okay to just go ahead and make their list. They know they're not going to miss any of the multiplication in the middle, and then they go from there. So it doesn't matter to me what method you use. I just want to make sure that you're showing me your work and that you don't lose those middle terms when you do your distribution. All right, so now let's look at an application question here. We have a square that has a side length of 2x plus 5. What is the area of the square? So draw yourself a square. Draw yourself a picture. Whenever it starts talking about a picture of something, it's really good for you to draw that picture out. So draw yourself a square. You have a length of 2x plus 5. Now, what we know about squares is that all sides are the same. So if this length is 2x plus 5, that means this width is also 2x plus 5. Some people like to call that base and height. So think back to geometry when you did some geometry back in middle school, and you had the area of a square. Area was equal to side squared. Or you could say that area was equal to base times height. So we know that we have a base of 2x plus 5, and we also have a height of 2x plus 5. So I can take those two things and I can multiply them together for my area. So my area is going to equal 2x plus 5 times itself, 2x plus 5. And what ends up happening is, you guessed it, I need 2 sets of distribution. So I need 2 sets of distribution there, I need 2 sets of distribution there, and I make a list of my terms. So 2x times 2x is 4x squared, 2x times 5 is 10x, 5 times 2x in the middle is another 10x, and then 5 times 5 at the end is 25. Sorry, I kind of ran out of space there at the end. Hopefully you can read that. 10x and 10x together gives me, I have 4x squared plus 20x plus 25 at the end. So that's my area. I don't know the units, so I'm just going to call this units squared because it is a measurement. So since it's a measurement, I have to give it a label. And there you have it. One more question, calculate the area of the following square. So something kind of similar. I'm looking at area equaling base times height. And since we know this is a square, you could also say area is equal to side squared. Your side length here is x minus 4 and x minus 4. So you've got area equals x minus 4 times itself, x minus 4. So then I do distribution. I'll set up a box for this one. So if I set up a box, x, negative 4, x, negative 4, x times x is x squared. X times negative 4 is negative 4x. X times negative 4 again is negative 4x. And then negative 4 times negative 4 is positive 16. My like terms are on that diagonal. That's x squared minus 8x plus 16. That's my area. And again, I don't know the units, so I'll just call it units squared. Every question with words needs an answer with words. Just keep that in mind. That's a little phrase that I like to tell myself. Every question with words needs an answer with words. So if you're looking at an application question like that, you need to have some sort of label. So, all right, this takes us to the end of our notes video for today. Thanks for listening, and I will catch you next time.